There are various different patterns for deploying your services. In this section, we're going to look at the multiple services per host pattern. So this is a fairly traditional approach where you have a machine, could be physical, could be virtual. You're likely to have given it a nice name because it's sort of a relatively long-lived actual machine. And then what you do to deploy your services is you actually would run multiple service instances on this host. And the actual services themselves could be a process. Each service instance could be a process. So it could be a JVM. It could actually be a Tomcat instance. That would certainly be one strategy. Another option is perhaps within one process, you're actually running multiple service instances. So for example, each service instance could be a WAR file, and you run multiple WAR files on the one Tomcat. You could use OSGI. Each service instance is an OSGI bundle, and on one OSGI container, you actually run multiple service instances. So that's the overview of the multiple service instances per host pattern. And it's arguably a more traditional way of deploying applications. There are various benefits to using this pattern. So one is you actually get very efficient resource utilization. You have one machine, which might be one virtual machine, and then within it, you would actually have multiple services. So that's the overhead of that OS and the machine is shared between all those different services. If you actually have multiple services running within one web server, for example, that gives you even more efficient resource utilization. You also have relatively fast deployment. In order to deploy a new version of a service, you simply have to copy it onto that machine and restart Tomcat or restart the process. It's actually quite straightforward. So there's some significant benefits to deploying applications this way, but then there's also some significant drawbacks as well. You actually get little to no isolation between the various service instances. Say each service was its own process. They're all running within the same operating system, and one process could actually consume all of the resources, all of the CPU, all of the memory on that machine, and impact the other services. It's even worse if those services are running within the same process. You get even less isolation at that point. So that's a pretty significant downside. Also, if you've got multiple services running within the same process, you get next to no visibility into how those services are behaving in terms of like CPU utilization or memory utilization, because for instance, they're sharing the same heap, so that's quite problematic. There's no real way of constraining the resources that a given service uses. And then there's a whole bunch of issues around version dependency version conflicts as well. And then last but not least, another drawback of using this approach is that whoever is deploying the service actually has to know what kind of service it is. It's a Java 7 Tomcat version XYZ service, and it has to be deployed in this way, versus this other service that's written using Node 0.10, for example. So whoever is deploying services has to have detailed knowledge of the technology stack used by each service, and then also know whatever mechanism must be used to deploy the service. So that's kind of problematic, and it introduces complexity, and it introduces risk of error during the deployment process. So sort of in summary, right, multiple services per host has some significant sort of benefits in terms of low overhead and fast deployment, but then there's a whole bunch of significant drawbacks. And it's sort of effectively, you can consider this to be kind of a legacy approach that is best avoided. And in the next sections, we're going to look at some more modern approaches that, for the most part, are much more preferable to this approach.